Afternoon, Richard Symons here from Schneider Electric. I'm part of the rack systems line of business, so we very heavily focus on rack power distribution, racks and enclosures, of course OCP being a big part of that, but also pod-based systems as well, which is what we're going to talk about today. So really the focus of this is how do we help customers accelerate their IT deployments with a rack-ready base pod system. So we've seen this challenge. This isn't necessarily new, that customers want to deploy faster. We embarked on a journey of customer feedback for the last couple of years to try and figure out some of the real challenges customers have when it comes to deploying their IT and what they want to achieve from that. So you can see some of the feedback we've received here, but really it bubbled down to three core things. And it didn't really matter which customer segment we spoke to, the theme was similar across all three. So we spoke to people from the cloud space, co-location, telco, enterprise, government, and it seems to be a general trend that customers want to find a way to deploy their IT much faster. They want to maintain or indeed improve flexibility. And then the final part, which I think is common always across all customer segments, reducing the total cost of setting up the white space and deploying IT. So really from the speed of deployment aspect, customers were telling us the quicker we can deploy our IT, the quicker we can turn on revenue generating services, or we can hand over the space to a potential tenant. So that's really a key driver that we tried to focus in on. The flexibility piece, it was more around the fact that different technology platforms are coming out. OCP is a fantastic example where it's not quite the same as what people have been doing traditionally. Customers have said there's challenges with deploying traditional and OCP style or other hyperscale platforms in the same pod or the same data center space. And of course, we know the innovation is not going to stop here. So we're expecting future platforms to come along that might change a little bit, whether it's from the power infrastructure side of things, the physical rack form factor. And again, that's going to present challenges. Flexibility is quite easy to address if you have a unique custom engineered thing, but it's not repeatable, it's not standardized, and generally there's cost involved with unique designs each time. So it doesn't really lend itself to the third one, which is reducing the total cost. Now when we say total cost, it's not just the hardware procurement side of it, it's actually the design of the white space. From your slab, what do you do from there? It's also for the labor involved with building out these pods. Again, if it's a unique design, there's usually one company, one organization who designed it, who can build it, and they're probably the only ones unless it's reverse engineered. And then the final thing is the ongoing life cycle of the white space. We know it's not just deploy and you're done. The white space outlives every IT platform that gets put in there, and the refresh cycles, again, present challenges when customers are trying to pull old kit out and deploy new kit. So let's take a look at why this is a challenge today. Why are customers feeling this pain and they have these goals they want to achieve? Well, first we'll look at the core infrastructure components that go into the white space. We have the branch level power distribution, we have copper and fiber cabling distribution, there's containment, and then of course the racks are the final piece that should be coming into the white space. When we look at, if we start with containment has always been very much a rack-based thing. So that's fine if you have a uniform rack platform, you never change it, refresh time, you keep the same racks. That is certainly a viable way to go, but pretty much every customer we speak to, they're telling us that's not what we're really doing. Whether it's something simple like we're deploying a SAN, for example, which comes in a proprietary rack that's different from our existing racks, or whether it is we've got a hybrid deployment of OCP style racks and traditional 19-inch racks. There's this variation that the rack-based containment systems don't really fit very well, and it doesn't allow that flexibility. Then we look at the actual design of the white space itself. You know, We see a lot of raised floors, absolutely. And it's all too common that we see this kind of scenario where what was once a well-planned out raised floor cable distribution system turns into something over time resembling this, which if you're also putting airflow under there, it can create obstructions. But we're also speaking to customers who are saying, do I even need the raised floor? I want to build on a slab, maybe I'm converting an existing space, maybe I want to simplify the whole design and have more of a warehouse style data center. Now of course, if you were traditionally putting power or data cabling under the raised floor, it's got to go somewhere. Now, we would argue that it's actually a better working environment if that goes up and over the top of the racks anyway. Which kind of leads to the other picture you see where people are putting threaded rod into the ceiling. It's quite a construction process. On day one, that's fine. When you come to a refresh and something needs to change, it's not ideal to have construction going on in the white space while active IT kit is running. So certainly there's challenges with doing it that way. You can have structural ceiling grid systems as well. And again, they can support all of that infrastructure as well as the power distribution. There's a cost associated with doing that also. So we wanted to see if there was a better way to avoid construction going on in an active white space environment, making it simpler and perhaps doing things a little bit better than we've done in the past. So couple these traditional challenges with some of the shifts that we're seeing at the rack level, if you like, or the IT deployment level. We spoke about this in an earlier session. We've seen Intel talk about this as well. The old unit of compute was, it's the use space. Well, now more and more, and OCP is a fantastic example with the wide network of solution providers and system integrators. No longer is it measured in use space, it's measured in rack spaces. And it's, people refer to it as rack scale. The rack is becoming the new increment of IT, and by default, when we look at it on the white space level, we're not building out in terms of racks, we should be building out in terms of pods. Most people will be doing this, whether they're aware of it or not, because when you put in the branch level power distribution, you have a certain amount of power that goes to a panel, you calculate your average density, and it goes down from there. So these kinds of things are happening, but bringing it all together in a simple pod-based design that can alleviate some of the traditional challenges, that's where we've really focused our attention. So we launched an offer, it was probably mid last year, called HyperPod, and it was exactly that. It's a freestanding frame. So you can see there's no racks involved here. It can go on a concrete slab. If there is a raised floor, it can go on the raised floor. And we put a variety of different mounting locations, whether somebody is running A and B busway feeds, or if they're using something more aligned with an RPP system for power distribution. You can put all of your copper tray on there, you can put your fiber runners on there, and all of this can be built out before a rack ever enters the data center. So that has a couple of advantages, that if you're getting your IT racks fully integrated by a system integrator, there's some time savings there because you're not having to rack and stack on site. But if you then bring this rack into the white space and then you have to build containment, then you have to put the cable tray in the right places or things like that, it can lengthen the overall deployment time. So it's, we've used this in a lot of data centers in North America and Europe. It's being launched globally in June, and we're already getting great customer feedback in terms of their time savings and their cost savings. At the same time, none of these environments that they've been installed in so far have been a uniform rack design. It's all been very varied, so that flexibility without unique customization, it's supporting that as well. So again, just to kind of highlight the three things we're trying to achieve with HyperPod, and we are achieving, it's that increasing the speed of deployment, very simple design. Once you get to look at the nuts and bolts of this thing, it's very simple to put together as well. It doesn't require particularly skilled labor to put this together, to the point where most of our customers, they buy this thing, we teach them how to install it once, and they install it from there on in. So they can use their own labor, whether they have contractors they like to use or whether they have labor within their workforce that could do this. So that's one thing. The flexibility I mentioned, every deployment we've done has been a mix of different rack heights, rack widths, the scalable pod design. You can see here just one section, which is an 8 to 12 rack section. It's telescopic, so it scales to exactly what racks you're putting in there. And then it builds out from there. You just add additional sections, so the typical pod size we're building to at the moment is about 50 racks. Lines up with the power distribution side of things, lines up with what people want to do in terms of space, and also it's within the limits of reasonable means of escape and health and safety. And then in terms of the cost side of it, there's a couple of elements here that we'll focus in on, just so you can see where some of the cost savings are. Our Science Center team did a study for a traditional white space build out versus one using this HyperPod system supporting all of the network infrastructure and the power distribution. So when we look at it, there's many different details here, and we'll provide more information, so if you want to dig into the detail, we have it. But the key wins here are the ceiling grid construction. It adds a lot of cost. If with the HyperPod system, you suspend everything from the pod itself, you don't necessarily need that costly ceiling grid system, or you can minimize what's actually being installed. It doesn't have to be fully burdened with everything you're putting in there. The second one there is the raised floor. I mentioned that. Again, if you're happy operating on the slab, you can eliminate that cost entirely. But some people still like it. Maybe it's for airflow distribution, or they already have an existing environment with one. But certainly you don't have to make space for all of that network cabling and power cabling going under the raised floor. So even if you still have one, it doesn't need to be as deep, because you're not operating in that space, and you don't have to support so much cabling going under there. And then the final piece to focus here is way over here on the left is, or the right as you sit, is the frame-mounted power distribution panels. So we did this study. You could swap that in with a busway, for example, but for this study we did end-of-row power distribution panels. Again, very simple. People have been doing it for years, but traditionally it's mounted on the wall. There's work that goes into that, then you're running your cabling over to the pod. All we did was bring those panels to the pod, so installation of the panel is now 3 screws, and that's mounted to the panel. All of the power distribution for the branch level goes up and over, and then it just terminates in the junction boxes, A and B feed above each rack. So it very much simplifies it, and you can see, again, those 3 areas make up a large proportion of the savings we're talking about. Now let's look at the time savings part of this. We did a typical project plan for a white space fit out. Again, you can see all of the subcomponents there, and we have the additional data, but very much here, a lot of the activities become parallel instead of sequential, and that saves on overall deployment time, to the point where the pod has the network ready all the way down to just terminating above the racks. It's ready to go. The power is the same. That's being done while the solution provider or system integrator is integrating all of that IT kit elsewhere. So when that rack comes in, it gets rolled in, plugged into the pod, connect the network, connect the power, and it can be up and running as quickly as that. So again, we do have a lot of resources to support this. I don't have time, obviously, to go into great detail, but we have a white paper detailing all of the numbers and facts and figures behind those cost and time studies. It was done on I think it was a 1.3 megawatt data center, but we also have a 5.2 megawatt pod reference design there as well. We also have trade-off calculators where you can use for pod sizing and things like that. And finally, I'd welcome you to join us over in the far corner by the coffee area, where we have, it's a chopped down pod. Obviously we didn't have enough space to put a large pod in there, but we have a small pod, so you can see the very simple construction methods. We've got the power distribution built in there with our Square D offers there as well. So you can really kind of kick the tires on how we actually put this pod together. So I'll leave it at that as time's running out, but please feel free to visit. We've got a lot more resources here as well. This is something we're actively rolling out today, so it is available. And yeah, please come and join us. Thank you.